Okay, so what we did for the last 3 days is we've been finding probability. Probability is the chance that an event occurs. And if you remember, probability was equal to the number of favorable outcomes divided by the number of possible outcomes. Well, today we're going to focus in on that denominator, the number of possible outcomes, and we're going to practice finding out what all the different outcomes are. So if I ask you how many possible outcomes are there when I flip a coin, you would say there are 2. But if I ask you for the sample space is the set of all possible outcomes in a probability experiment. So the sample space of flipping a coin would be heads and tails. We know there are 2 outcomes, but actually listing what they are is the sample space. So rolling a dice, what would be the sample space there?
1, 2, 3, 4, 5, 6.
It is 1, 2, 3, 4, 5, 6, listing all of the possible outcomes.
So if we get like a card, probably have to put like spades, jacks.
You're going to list every possible outcome. And we're going to make it a little bit more complicated. Like we may do something like, what if I flip a coin and roll a dice? Then how many possible outcomes is that?
Tails, heads, 1, 2, 3, 4, 5, 6.
But
8. No.
it's not. It's more than that. That's what we're going to go over today. It's how many different outcomes there are when we have compound events like that. So what we're going to use, we're going to be using a tree diagram, and it's going to display for us the sample space. A vendor sells vanilla and chocolate ice cream. Customers can choose from a waffle or a sugar cone. Find the sample space for all possible orders of 1 scoop of ice cream in a cone. Okay? And so we essentially have 2 decisions to make. We have to first to decide what kind of ice cream, and then we have to decide what kind of cone. So this is the way that I make tree diagrams. Now when you see them, sometimes tree diagrams may be drawn sideways like this. Okay, but I always draw mine up and down like this. So I start here. Here you are. You don't have to draw you, but imagine that's your starting point. Okay, it's right here. So your first decision is what kind of ice cream. So how many choices do you have?
2.
2. So you're going to draw 2 branches on your tree.
Oh, it's like a food web.
Kind of. Okay, so then we're going to list what are those 2 choices? Vanilla and chocolate. And so that gets us to the first level of the tree diagram. Now the next decision, they can choose from a waffle or a sugar cone. So what if you chose vanilla? How many options do you have now? You have 2. You could choose waffle or sugar. What if you chose chocolate?
Still 2.
They have 2 options. Theirs would be waffle and sugar. So now the sample space, when we list it, is we have to go from our starting point down every possible branch combination. So we could have vanilla in a waffle cone. So that's option 1. Could be vanilla in a waffle. Okay, what's next? We could have vanilla in a sugar cone. Right, you see how I'm going down the branches? Go back here every time. So my second option is vanilla in sugar cone. Okay, now if I go down the vanilla branch again, there's nowhere else to go. I've already been down both of those. So now I go to chocolate. waffle. And then the last one is chocolate sugar cone. So there are 4 possible outcomes. And when it tells me to list them in a sample space, I have to tell what those 4 outcomes are. And right here they are. How many branches did it have? 2? Okay. And then what were your choices? Male and female. Okay. 3 from male. How many from female? Okay, then what were my choices? Yellow, brown, and black. Yellow, brown, and black. Okay? And then when we list the sample space, you could have had male yellow, male brown, male black, female yellow, female brown, and female black. So there are 6 possible outcomes. And right there we've listed them all. That is my sample space, is those 6 outcomes. Okay, so first things first, let's first find the sample space. So first thing, we got to pull out of bag A. So there are how many possible outcomes when we pull out of bag A? There are 2. I could pull a green marble, or I could pull a green marble. Now, in bag B, that's my second choice. Now I have to choose again. I could pull a green marble or a red marble. And then over here, I could pull a green marble or a red marble. So now we're going to find the sample space. So we have green, 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 red, green, 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 red. Okay. So that is the sample space. Now, secondly, we want to find the probability that player 2 wins. So now we're going to take this information that we know, and we're going to find the probability that player 2 wins. Okay, so how many total possible outcomes are there? There are 4. We just listed them all. Green, 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 red, green, 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 red. Now, how many of them allow player 2 to win? So let's go back and read. How does player 2 win?
Close the marble up.
If both marbles are the same color, player 1 wins. If the marbles are different, player 2 wins. So how many different ways could player 2 win? Well, the marbles have to be different colors. So do they win in this example? Green and green? No. What about green and red? Yes, that's a win. What about green and green?
Yes.
No. Green and red.
Yes.
So how many different ways do they have to win?
2.
2 out of the 4 possible outcomes. 2 over 4 reduces to be 1/2. So it's basically 50-50. They're just as likely to win as they are to lose.
I don't know if this is right, but
Well, that's okay.
I put where you start at
Uh-huh.
and put 2 lines down.
2 choices, okay.
And I put Delmar and Clara.
Why'd you put Delmar and Cara?
Because it says Delmar and Clara. Then I put how many? Put 3 lines from Delmar to also Karma. I put 1, 1, 1. So I have 3 times to flip the coin. And I put.
Yeah, so they're flipping 3 coins. So what's the first choice they have?
Flipping the coin.
And so what are the 2 choices?
Heads,
Or
coin, tails.
heads or tails? So you should, from that first choice, there are 2 possible outcomes. There are heads and tails. Right, because when we flip the first coin, we can't already determine if Delmar or Cara wins. They're not choosing the winner till after all 3 are flipped. So the first possibility, you could have heads and you could have tails. Then what's going to happen? They're going to flip the coin again. So what happens if they got heads the first time? What are their choices the second time?
Heads,
Or
tails,
what if they got tails the first time? What are their choices?
heads, or tails.
Right? So you see right here, if I stop, this is if they flip the coin twice. Look at the choices. Heads and heads, heads and tails. Tails and heads, tails and tails. Right? Those are the 4 possible outcomes if we flip the coin twice. But they didn't just flip the coin twice. They flipped the coin 3 times. So what if they got heads and heads? Then they've got another choice, right? They could have heads or tails. What if they got heads, then tails? Well, again, they could have heads or tails. What if they got tails, then heads? Well, then the next time they could get heads or tails. And then what if they got tails and then tails? The last time they could have gotten heads or tails. Does that make sense to y'all? You sure?
Did it a different way.
How'd you do it?
I did 3 on the top part, and I put coin, 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 and then I did heads and tails, like on the line out from under it. Then I did heads and heads, and then I did tails and tails.
Okay, but that doesn't show all the possible outcomes. Because right here, you can see if we go down the branches, all of my possible outcomes, when I flip 3 coins, I could get heads, heads, and heads. I could get heads, heads, and tails. I could get heads, tails, and heads. I could get heads, tails, and tails. I could get tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. Right? For my 8 different outcomes. When I flip a coin 3 times, there are 8 different outcomes. So now we have to list them. Heads, heads, heads. Heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Tails. Heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. Everybody sees where I got these from. Just following my branches down. Because event 1 was flipping a coin. Event 2 was flipping a coin. Event 3 was flipping a coin.
I was confused.
Yeah, that's okay. So I have done the first part. I have found the sample space. That is the sample space. All the possible outcomes. Now, it tells me find the probability that Del Mar wins. Okay, so just a quick reminder. First, we're finding probability. It's the number of favorable divided by the number of possible outcomes. So how many possible outcomes are there?
8.
There are 8. We listed them all. Those are the 8 possible outcomes. Now, how many of them let Del Mar win? Okay, well, let's read. What has to happen for Del Mar to win?
All heads.
If all 3 are heads, Del Mar wins.
So with one.
So there's only one way you can get 3 heads. So Del Mar has a 1 in 8 chance of winning. About 12.5%. So do we think Del Mar's going to win? No. It's a lot easier for Kara to win than for Del Mar to win. This is not very even odds.